All right, so we are moving into Auckland and sector area. Now the standard for today is I'm using property of circle to solve problems involving the length of the arc and the sector area, the area of the sector. By the end of today's lesson, you should be able to solve problems involving arc length to find the length of an arc and the area of a sector. We're going to quickly review circumference and area of a circle because it's going to be related. And arc length and sector area we're going to practice after we go through the property, how to use those two concepts. And then we're going to close out the lesson with any misconceptions, and we're going to make clarifications. Now, arc length and sector area, even though it's new, but we're still going back to review the inscribed, central, angle outside and inside because they're all related. We have another week for this unit, and then we're going to move into data and units. The tutorial is today, after school. I think Saturday school is next week. So if you need help, make sure you come to the tutorial today on Saturday school next week. Don't wait too late now. Today, after school.
Saturday school?
No, I think it's
Yes, we have
next week before.
We have Saturday school today. Saturday.
Oh, I don't. I'll be out of time. All right, so at arc length and sector area. Alrighty. All right, I'll review quickly circumference of a circle and area of a circle. Both the formula are on the formula page, so you don't need to remember that, but you need to know how to use it. You do not sit there and guess. Those formulas are given to you, and they are on your formula paper. And sector area.
You got a bachelor's degree?
I didn't hear anything about that.
All right, all done, right? All right, given a circle with the diameter of 20, what is the circumference and the area? Same with warm up earlier. Circumference is, I'm going to write pi d, which is 20 pi, right? And then the area is pi r squared, which is equal to 100 pi centimeter squared. Everyone agree? All right, now just take a look at the circumference. The circumference is where? The outside part. This is, if I start from here, how long I walk around this circle part, right?
The distance around.
The distance around. If this is the circle part, I go around the part, around and around, and see how long that was. The area is the inside, how much tomato sauce you have to fill for your pizza, right? So the inside part, that's it, the area. Now we're gonna go to arc length and sector area. I'm gonna erase this part And we're gonna take a look at the arc length first. I'm gonna divide this circle into 4. And I want to find how long is it from here to here. Who has the idea of how to find out this?
You know the half of it is the what is it called when it's half?
Semicircle?
Yeah, the semicircle is 80, and we just divided the 80 semicircle and then half again, and we know half of 80, or 180 is 90.
Okay, so you say this angle right here is 90.
Yes.
Okay, so this angle right there is 90. What else?
You know it.
All of them 90. So all of them are 90, okay.
And from that we know that the arc measurement is also 90.
The arc is also 90, okay.
How do you know that?
Because the inside is not
Because they're congruent.
Yeah.
So pretty much you are telling me this part, right? The arc, the measure of an arc. Equal 90 degrees, right? But I'm asking you what is the length of the arc? That's the question.
So you're right, central angles do equal their arc, but that's degrees.
So you asked
We're talking length.
The measure of this arc is 90, right? Because you're central and arc are congruent. But I'm asking you the length of an arc. How long do you have to walk on this piece? How long do you have to walk on this arc?
So you're talking 90 degrees, but we want to know in centimeters what it is. What's the distance around?
Could we use the pi?
You know the circumference, the whole circle, if I start from here, I go all the way around, how big that was?
20 times pi.
20 times pi, 20 pi. So if I want to go from this point to here, how long was it? How you find it?
5.
5, how do you know? 5
Because
was
it's 4 different areas, and if you divide 20 into 4 and 55.
So you take this number and you divide it into 4 because you have 4 equal pieces, right?
Yeah.
So your answer will be
5 centimeters.
not 5. 20 pi divided by 4 gives me
Oh, wait. 15.7.
which is 5 pi. Right? 20 to go into 4, then divided by 4 is 5. The pi carried out. Right?
And then you need your units.
Which is centimeter.
I said 5 centimeters.
Huh?
I said 5 centimeters.
Centimeter.
5 pi, yes.
Because you only go 1/4 of the circle. Right? You have to be able to distinguish between length of an arc and the measure of an arc. One is in degrees and the other one is in centimeter, inches, units. All that. question mark. You will get the report. All right, all done, correct? Now, how do we know to find the length of an arc? It's very easy. If they give you a 90 degree and divide a circle into 4, but what if they don't divide it into 4, they divide it into certain degrees? So, let me ask you this. This is 90 degrees, right? 90 degrees here. What is the whole circle? 360. So the whole unit, the whole circle is 360. And one piece here is 90 degrees, right? What number did you divide by? 4. So what's the relationship between these two numbers? How do you find that relationship? It's easier for you to remember that. Huh?
9 times 4.
9 times 4. So it's really not you telling me 90 times 4, right?
360.
So this piece, if we're talking about ratio, this is 1 hour math work. If this piece is at 1 hour, how many? This is the part hour 4. So if I can write this as 90 divided by 360, will this simplify to 1/4?
Yes.
Yeah.
Yes?
0.25.
Okay, so if I take the angle measurement or the arc measurement divided by 360, I will have the ratio that when I multiply with the circumference, this will give me 5 pi, right? If I take 1/4, I multiply with 20 pi. Is it the same with 20 pi divided by 4?
Yeah.
Which is equal to 5 pi? Yes?
Yes.
So, can someone come up with a general rule how to find a circumference? I mean the arc length. Check. Check the circumference. Okay, the circumference is here.
Multiply it or divide it by the parts.
The ratio of
The circle.
the
Angle.
the arc measures or the angle measurement divided by and the whole circle, right? Yes? Question on that part. So to find arc length, you take, it's gonna be equal to take the measure of arc or angle, you divide it by 360 and you multiply by pi d. Let's do this part, circumference.
Will it always be 360?
Yes.
Why will it always be 360?
The circle wall.
Because you always, the circle always has 360 degrees. So what part of that is going to change?
Times circumference. Times circumference, yeah.
The measure of arc and the circumference.
The circumference will be the same formula though, right? Because the diameter is the only thing that may change, but yeah. So it'll always be 360.
Total length.
Actually, the process of- Please. Sam.
All right, so that was the arc length. We're gonna practice on that in a minute. Now we're gonna go to sector area as well. I think I should draw an animation. So given the same circle with diameter is 20, the area is what? What is your area in your warm-up? Uh-huh. 100 pi centimeters square. Everyone agree? All right. Again, I'm gonna divide this circle into 4 again. I cut the pizza in 4. This one is still 90 degrees, right? And I want to know how much pizza I had. Yeah, how much pizza did I eat?
That would be sector area,
So,
just the
1/4
area
what?
of that.
You take 1/4 of what? 1/4 of the pizza. So if the whole pizza is 100 pi, 1/4 of the 100 pi would be what? Which is what? You ate 1/4, right?
Which is typically 0.25%.
So 25%.
Yeah.
So a whole is 100 pi. So what is this small piece then? 25% of 100. How do you find the number? I need the number. Uh-huh. What's that number? Miranda, please sit up, ma'am. The whole piece is 100 pounds. What is the small piece?
45.
Any question on that part? How you got 25, Claire?
Because it's 4 pieces, you look at it like it's 4 quarters. So each piece is 45.
Right? So this is 25 pi, that makes 50 pi, 75 pi, and 100 pi.
So if you shade one is 25 and you shade two is 50.
I'm sorry.
Yes.
Peter.
Yeah.
Yes.
So pretty much you took this number and you divided by 4. So pretty much this equal to 100 pi divided by 4. And this is the sector area. And how do you get 4 here? Going back to the offering, how many pieces you get? So 4 is mean that because 90 divided by 360, this ratio gives you 1/4, right?
Right.
So pretty much you take this and do 100 pi, you multiply it with 1/4, right?
Right.
So this ratio 1/4 is the ratio of the arc or the central angle divided by the whole circle and multiplied by the area.
So it's easy when it's divided into 4, so you've got to remember that ratio.
So what's like the general rule?
The general rule would be what? Area of a sector equal what?
That's what equal right quick. Equal right quick.
Go back.
Yeah.
You say come here real quick.
This is the ratio, right? So we're gonna have what? Brother? Yes, Alvin? Brother?
Hold up. Alright, go ahead.
All right, so what's the thing? What's the ratio? 1/4. So how do you find 1/4 again? You take what divided by what?
90 divided by 360.
So pretty much it's the measure of arc divided by the whole circle and multiplied by what? Area. Remember, area of a sector related to the area of the circle. The length is go with the circumference because the circumference is pretty much the length, how long you walk around a circle. So this is partial of the circle, and this is the partial area of the area of the circle. A is the area. These are not on your formula, but the C and the A, circumference and area are your formula. All you have to remember is that this ratio, this is the important part. The ratio multiplied by this, and the ratio multiplied by the area. Right? Yes?
How many questions gonna be like this?
As far as I know, it's about 1, 2, or 3. It's 2 or 3. It's good chance though. All right, let's look at our example real quick. All right, find the length of an arc AB. Go ahead.
What's that angle?
AQB.
No, what's the measurement?
30.
Oh, 30.
Given angle AQB is equal to 30 degrees. The radius is 15 centimeters.
Huh? I'm trying to understand.
So does everybody know what AB is in degrees? 30 degrees. AB is 30 degrees.
All right, so arc AB is 30 degrees. Why?
Because the
Inside
angle,
Okay, the measure of arc AB is 30.
Because angle AQB is what? And then what kind of angle is it? Central angle, that's right.
Because central angle, right?
Central angles and their arcs are the same in degrees.
Right, so if this angle arc right here is 30,
What's the next step?
what's the next thing?
is the area.
The circumference is
How do you find it?
30 times pi
So pi is pi. What is D?
30.
30. How you got 30?
Because the radius is 15. So
Okay. So make sure you do that part.
Where is the radius? How do you know it's 15?
Because the radius is QB. And 15 times 2, that's going to be 30 going straight across for the other half.
That's right. Make sure you guys get that written down.
The problem can be giving you a radius, or they can give you a diameter. You need to be able to go back and forth between radius and diameter. And a lot of people mixing D2, they're gonna start using radius in the formula. So either way, you need to be able to go back and forth. And again, the formula is on the paper. Do not go sit there and guess. All right, next part to find the arc length.
You have to find the ratio.
Arc length. I'm gonna put everything in one place. The ratio is what?
It's 30 over 360.
30 over 360
One.
multiplied by 30 pi.
Going back to the 30 over 360. 30 is our part, right? That's what we're looking for, right? AB.
I got 1 over 12.
And then the whole thing is 360. Every circle has 360.
Yeah, I simplified.
I got one.
If you simplify it down, it's 1 over 12.
1 over 12.
Yeah.
It means pi divided by 12.
Yeah. No, 30 pi.
No, I'm confusing you.
Well, okay, you see 30 over 60. Yeah. If you simplify that down like you did with 90 over 360, you got 1 over 12. Where in the other problem, we got 1 over 4.
Yeah.
Like this.
Yes.
And what's next?
Multiply.
What?
You to put 12 under 30 pi.
You put 12 under 30 pi, okay?
Yes. And I got
Or you
seven-
can use calculator and put the whole thing in. The way
Yeah.
it is. What is it equal to?
I got 7.85.
4, 5 pi over 2.
4,
5 pi over
I like that one. Thank you, Ronika. 5 pi
2. Over 2.
over 2. I like this part.
Does everybody know how to put pi in the calculator?
There's a what? They say pi.
I wasn't using pi. I was using 101.
If you don't know where pi is on the calculator, ask your neighbor.
It's over the. It's next to the sin button.
Oh.
Sign button. Whatever.
When we work with the circle unit, the circle, you can leave answer as pi, but you need to be able to convert this pi into 3.14. Now, personally, and for most of the math, people, they usually leave pi here because if you use 3.14, it's not the exact number. It's just a long list of numbers after the 14. So usually I would use pi, unless they're asking me for the approximate of length or area. Then I put pi into 3.14. But other than that, I'm going to leave this at pi. Question, concern?
So it's really easy when he's talking it through. It all makes sense and it's easy. But when you started doing it by yourself, you were like, now what do I do? What do I do? So make sure in your notes you're explaining things to yourself, because you're the ones that have to understand those notes when you do the worksheet and the homework.
And oftentimes, do you see that I have to ask questions so that it make it clearer? So you have to ask yourself those questions when you work on the test. Don't rely on someone else next to you.
Okay, I got it up to 120. I got it up to 112 times 35. Then how you got 5 pi divided by 2?
Just put 1/12 times
Yep.
30 pi in your calculator.
Instead of putting in 3.14. you
Does
just
everybody
put
remember
five.
how to put a fraction in? How to push the ND button and put 1/12?
Yeah. My guy is stupid.
Okay, I got you.
Y'all calculator needs to be in math rings. Math rings.
Math what?
Math print.
Math print?
Print, not plastic.
Stop touching me.
Go back to your seat. Come on.
If it's on plastic, it's gonna give you decimal
That's your seat.
and funny looking fraction. All right, any question on that part? So we good, we ready for practice? Yes? The first 5, 7 questions pretty much just review circumference, going back and forth between the formula because you will need that. Going back and forth. Circumference and area. And then pretty much practice start from 8 to 16 and then up to 20 on the back. Especially number 19 is the challenge one.
I'm not gonna know. The ones that I pick over there. And if you want to shorten it,
Let's work on this one. This is your time. This is not on nail class. What? C is that. C stand for.
This is the diameter.
But you didn't do anything. Aye. 48 is already over now, right? Yeah, it's already high then. 20 high means that 20 humans to like, but about 3414. But we decided to leave high in there, we don't want to like that. So,
And since on squared,
and that's giving you what, 15.27, that's what I said. What is it? What is it? What is that number? That one. You take 48, you divide it by pi, you by what? Which is?
so the other way.
Which is what? Yeah, you take the circumference, you divide it by pi, that's gives you 15.27. What is that number?
I don't think so. I
Right
don't
here.
know anything about it.
But what that number tell you? What is that number? Diameter? How you know? Number one is on 7, right?
If it wasn't radius, yeah, if it wasn't circumference, it would even radius.
It's the diameter of radius.
I haven't heard anything about advisement.
So I come to you to my library.
Right.
I don't think I'll.
Mr. Nguyen.
That's where it's
So I go to the library before I go to my 4 o'clock.
Here's Mr. Nguyen.
I go to the library before I go to my 4 o'clock.
Yeah, I send out an email